Good morning everyone. Welcome back ma. In the last class we have completed up to net force, right? We have completed the topic of net force. What is net force? The net force is nothing but the resultant will be 0. Yes or no? Is the net force is 0 or anything? Technically we say that the net force on the object is 0. That is known as a net force. Okay. Now we'll do the activity 9. In what is the to know detail about your net force. Okay, effects of net force acting on a table. We'll see how the effect will be acting on a table. That net force how can acting on the table, we'll see now. Okay, see here, try to push a heavy wooden table. Is it hard to push? Tell me. If you want to push any heavy wooden table in your homes, a wooden table is there, right? If you push that table, is it heavy or is it very easy? Tell me. Ask your friend to help you in pushing the table in the same direction as shown in the figure. Okay, like this. Just ask your friends to push this table in the same direction as shown in this figure. Okay. Do you find it easier to move the table now? Yes. Why? Why? Because here so much force is acting on a table. Okay, two forces are acting on a table. That's why if anybody is attached with you, then it is very easy to move the table. Yes or no? Yes. If you want to move the push the table alone, that is very heavy, harder to move. Yes or no? Yes. You may notice that it is easier to push the table when you take the help of your friend. Okay, the force applied by your friend added to the force exerted by you results in the both forces being applied on the table in the same direction. Yes or no? In the same direction the forces can be acting on a table. Okay, the total force applied by both of you made it easy to move the table. Yes or no? The total force you can apply the both of your forces acting on a table, that is easy to move. Now ask your friend to push the table from the opposite side as shown in the figure. Now what you have to do, just ask your friend to push the table on your opposite side. Okay, then what happened? What happened if it moves? Then in which direction does it move? Is it any change? Tell me. When you and your friend push the table from opposite sides, the table doesn't move. Yes or no? Why? Because one force is acting on acting on this direction and another force acting on this direction. Yes or no? So it is a net resultant force will be a 0. If both of you apply force with equal magnitude, let us assume that one of you exerts a large force. What will happen? See, in that two forces, if one will acting on a large force. Okay, now what will happen? The table moves on that direction only. Yes or no? Yes, now we'll see that one only. All forces have both magnitude and direction. While adding forces, the directions of forces have to be taken into account. Yes or no? The direction should be taken into account when you want to when you want to exert a force. Okay? When forces acting on a body along a straight line and they are in the same direction, and net force is taken as the sum of all forces acting on the body. Okay? To add forces, sign convention must be used. So what he is telling is, if the forces acting on the same direction, what you have to do, just you have to add the forces. Whatever the forces are acting on a body, that forces you have to add. Okay, and you have to keep the sign convention also. Okay, if they are in the same direction, you should keep positive sign. If they are in opposite direction, you have to keep negative sign. Okay, as shown in the figure, above figure, the force F1 directed towards right. Yes or no? This is your F1 and this is your F2. This F1 is directed towards right side. Okay, could be taken as positive. And the force F2 acting towards left could be taken as negative. Okay, these are the opposite directions. So you have to take this direction as positive and this direction as negative. From left to right you have to take positive direction, and from right to left you have to take a negative direction. Okay, you have to just if you are having us opposite directions. Okay, then the net force should be F1. See here, F1 plus or minus F2. Why? The positive sign is F1 and the negative sign is F2. Why? Because it is the opposite direction from this direction. Yes or no? So the final totally the net force will be F1 minus F2. Okay. When the forces on a body in a straight line are in opposite directions, the net force is equal to the difference between two forces. Okay. By this, what you can conclude, ma? By this statement, you can conclude that the forces acting on a straight line, if any forces acting on a straight line and in opposite directions, okay, opposite directions, the net force will be what? What happened to the net force? The net force will be the difference of the two forces. Okay. That is your statement. The object at rest moves in the direction of the net force acting on it. Okay. The net force, whatever the acting on it, the object will be net force acting on the rest body. Okay. That is about effect of net force acting on a body. Now we'll see effects of stretched rubber bands on fingers. Okay. This is also one more activity. We'll see what is that. Okay. Effects of stretched rubber band. We know already a stretched rubber band is what on fingers is if you elongate, then it will be stretching. What is that? We'll see. Okay. Take a rubber band. Do this activity, all of you. Take a rubber band. Stretch it using your fingers. Okay. Just take a rubber band. You have to stretch like this. Okay. Stretch. When you stretch the rubber band, it exerts force on your fingers and you feel the force of pull on your fingers. Yes or no? While stretching, what happened? You have to exert some force with your fingers. Yes or no? What happens if you add one more similar rubber band around your fingers and stretch both together to the same length? What happened? Do you feel the combination of two bands exert a larger force than that of one? Is it exert a larger force, ma'am? Yes, definitely it exerts a larger force. Well, when one rubber band is stretching, it is acting a small force. When two rubber bands are stretching, it is act as a large force. Yes or no? Increase the number of rubber bands around your fingers and observe the force exerted on your fingers by the rubber bands. What will happen? Any guess? Let us say the force exerted by one rubber band is F units. Okay. Now we'll see one rubber band force is F units and the force exerted by the second rubber band is also F units. Okay. Consider the force of rubber bands as F units. Then what will be the net force of two rubber bands? We can express it as this is your first rubber band force and this is your second rubber band force. Now you should you have to find out the net force, means just you have to add these two forces. Okay, then it will be coming as 2F units. Yes or no? This is your 2F. The net force is 2F. The unit of force in SI system is Newton. This is very important. In SI units, the Newtons means force units is Newton. In SI units, unit of force is Newton. Okay. What is the net force acting on your finger when 3, 4, etc. rubber bands are used? What happened? Tell me. It will increase. If you are stretching 3 rubber bands, then it will be a 3F. If you are stretching 4 rubber bands, then it will be 4F, like this. Okay. Next, we'll see how to calculate net force from free body diagrams. Okay. From free body diagrams, we'll see how can we calculate the net force. Okay. See here, the diagram showing all the forces acting on an object at a particular instant is called free body diagram. Okay, what is meant by free body diagram? Actually, the body which is having a forces acting on an object at a particular instant, means at a particular position the forces acting on a body is known as free body diagram. This is the example of free body diagram. This is a particular force acting here. Force acting here, force acting here, also one particular force is acting like this. If you are having any particular forces acting on a body, that is nothing but free body diagram. Okay, now we'll clarify what is how to calculate the net force from free body diagrams with an example. Okay, see, let a car be moving with a uniform non-uniform speed along a road. Okay, what happened? A car is moving with a non-uniform speed in the road. Okay, what are the forces acting on the car? Tell me, what are the forces acting on the car? What is the net force acting along the vertical direction? What is the net force acting along horizontal direction? Now we'll see what are the forces acting on a body. Okay, Draw all the relevant forces acting on the free body diagram. We called it acting on a body. Okay, just you have to draw what are the relevant forces are acting on a body. Just that you have to draw. Okay, see here, choose a coordinate system. Clear? With x-axis and y-axis as shown in the figure. This is your coordinate system of x-axis and y-axis. Okay, sign convention should be taken along x and y direction. This is your positive direction and this is your negative direction for x-axis, and this is your positive direction and this is your negative direction for y-axis. Okay, next, add forces algebraically with sign conventions along x and y axis separately, then those values give net force along x and y direction. Okay, now we'll see the forces acting on the car as are shown in the free body diagram. They are, okay, what are the forces acting on the body? We'll see now. Force applied by the engine. Okay, engine is here, you have to just engine force is also acting on a body, yes or no? That can be considered as F. And friction applied by road, that is small f. Friction between the road and the wheel of the car of the wheel is acting on a body, that is force exerted is small f. Okay, normal forces are N1 and N2. These are the normal forces which we are considered as N1 and N2. Okay, now gravitational force definitely it will act on a car, yes or no? That is considered as W. Clear? Now net force along x-axis or direction. Okay, x-axis means here these are the x-axis means what are the direction, what are the forces acting on x-axis? Tell me. The net force acting on x-axis is F, and here also F. Okay, here F, small f, frictional force and engine force. Okay, the both are in different directions. Okay, this is here in this direction and this is in this direction. So you have to keep a negative sign. Okay, clear? Both are opposite directions, so you have to keep negative sign. Next, net force along y-axis. Now we'll see what are the forces acting on a y-axis. N1 and N2 are the forces acting on y-axis, yes or no? And W also. Okay, on y-axis, yes or no? These are your x-axis and these are your y-axis. Perpendicular axis are nothing but y-axis. Okay, now what are the forces acting on y-axis, ma? N1, N2 and W, yes or no? And N1, N2 are the same direction when compared to the W. W is in opposite direction. Okay, now N1 plus N2, this is opposite direction, so you have to subtract with these two directions. Okay, N1 plus N2 minus W. Clear? This is your net force along y-axis. Okay, these are the forces acting on a free body along your axis. Okay, here some of the questions are given, 3 questions. Just you have to read and write these questions, think and discuss. You have to write in your classworks also. Okay, this is your clear. This is your homework, today's homework. Just read the lesson up to here and you have to write the answers in your classwork. Okay, if you are having any doubts regarding this, just call me, I will tell you. Okay, ma? If you are having any doubts, call me. We'll meet in next class. Okay, we'll do the more activities. We'll do more activities in your next class. Clear? Okay, ma. Bye. Thank you.